Welcome to the first real episode of my new series about how the internet works. In the first few videos, we will start by taking a look at the protocol stack and various things that go into sending and receiving data over the network. So what problem is the protocol stack trying to solve? Well, there are a ton of different technologies that are necessary to send and receive data over a network. Be it for making sure that all the sent data actually arrives, routing pieces of data through the network and ensuring that it reaches its destination, or hardware stuff like Ethernet, Wi-Fi, Bluetooth, LTE, Li-Fi, glassfiber, satellite uplink, and many more. Without a common network stack, each operating system would need to build its own. This would be detrimental for intercompatibility. Just imagine trying to access a web server running on Linux, but you are using a Windows PC, so you can't do that. That's why it's important that everyone uses and understands the same suite of protocols. This suite is called a protocol stack. There isn't really just one protocol stack though. Each operating system used to do it in its own specific way, but nowadays every relevant thing uses the TCPIP stack. But there are also others like the one that we will focus on in this series, which is the OSI model. TCPIP is the one that's kinda won, as it contains stuff like TCP, UDP, IPv4 and 6 and many more. But we will also look at the OSI model as it spreads its protocols over more layers. While TCP/IP has only 4 layers, OSI has 7. There's nothing wrong with either approach, but having 7 means that I can squeeze out more videos. And we can take a more detailed look at all the different steps in the process. The protocols of the OSI model are all irrelevant, but we will instead just stuff all the TCP/IP protocols into the OSI model. As I already said, there are 7 layers in the OSI model. The next 7 videos will all look at one of the layers. We will work our way down from the top to the bottom, starting with the application layer, which contains protocols like HTTP. These are the top level that a user will directly interact with. The presentation layer is next. This one is important for formatting the data for the application layer. Here are protocols for encryption like SSL and TLS, but also things like ASCII. After that follows the session layer. You can think of this layer as the connection between the application and the network. Here you can use something like sockets or named pipes. The transport layer handles the transport over the network. It has to try its hardest to get all data from A to B without losing any, if using TCP. With UDP this is a little bit different. Routing the data through the vast internet is the responsibility of the network layer. Here are all the protocols for routing traffic around and addressing everything with IP addresses. Bringing the data to the next hop or node is handled by the data link layer. It contains stuff like MAC addresses and everything that goes with that. The last layer is the physical layer. This is the layer that will actually send the data over the connected medium. If using an Ethernet cable, it will transform the bits into electric signals, with Wi-Fi into radio waves, and so on. That's already everything for today. If you want to get notified about the next one, then you can leave a sub. Please also leave some constructive criticism in the comments so I can improve my content. Thanks for watching and see you all next time.